Hi guys, hope you all are doing good. So in the previous videos we have learned how to insert a node at the beginning and at the end of the double linked list. So in this today's lecture we will learn how to insert a node at any position. So this is one of the most important interview questions. So let us understand it step by step. So without any delay, let's begin on today's lecture. Suppose we have a double linked list. Suppose let me write here. So we have the double linked list. So first double linked list start from null, backward 10, forward backward 20, forward backward 40, forward null. So this is our initial double linked list. So now we want to insert 30 at position 3, that means here. So third position means here. So after insertion the linked list will become the double linked list becomes 10, forward backward 20, forward backward, yes, 30, forward backward 40, forward null. So this is a final linked list. So how can we do it actually? So let us learn it step by step. Suppose imagine you have four friends standing in a line. So suppose these 10, 20, 40 are friends. So these three numbers are friends. So a new friend 30 wants to stand between 20 and 40. So first everyone adjusts their connections, right? Then 30 joins into the line. So the same happens. So 10, 20. So this 20, 40 gonna talk each other, that 30 will gonna come in between them. So after connections, after talking, 30 will come in between 20 and 40. Now this is will be the link. This is will become the new line. So in exactly the same way, the double linked list work. So first we need to create a new node. For that we are going to create a new node. First struct node. So let me write. So let me erase. So struct node, we are going to create new node. For that we need to write start new node. So this is the new node. So first then we need to allocate dynamic memory, right? We are creating new node. So for that we need to create dynamic memory allocation using malloc function. So using malloc function we allocate dynamic memory. So this new node have some data, right? So for that we need to write new node data. New node data equal to what? New node data equal to 30. Yes. So on the second step, we need to reach the previous node, right? Since we are inserting at the third position. So for that, we need to stop at position 2. If you're gonna insert an element at position 4 means we need to stop at position 3. If we are inserting at position n, we need to stop at position n minus 1. So in the same way. So in this our example, we need to stop at position 2. For that, we need to create a temporary variable. For that, we need to write struct node start temp. So initially temp points to the head. So initial temp points to the head. So this is. So now we need a for loop. So we're going to get for loop. Int I equal to 1. I is less than position minus 1. So like I didn't declare position right here. So the position is 3 actually here. So position 3. So I is less than position minus 1. I is incremented. So we need to write here temp equal to what? Can you guess it? Yes, temp equal to temp of next. So this is. So we have successfully created a for loop. So now temp points to the node 20, right? So on the step 3, we need to update 4 pointers. So this is the most important part. First, we need to update the new pointer first. First, we need to write new node next equal to temp of next. So this is the first node. We are going to update the first value. So this is the first one. On the second, we need to update the node previous. So node previous becomes what? Can you guess it? Node previous become, yes, you guessed it correctly. Node previous becomes temp. On the third line, we are going to write temp of next. Temp of next previous. So temp of next previous equal to what? Is equal to new node. So this is. So on the fourth line, we are going to write temp of next equal to new node. So temp of next equal to actually equal to new node. Yes, temp of next equal to new node. So now all connections are correct. Now the final linked list will become, it's gonna be null backward 10, 20, 30, 40, and another. So this is the final linked. I mean, the insertion is successfully completed. So remember these four lines: new node equal new node of next equal to temp of next, new node previous equal to temp, temp of next of previous equal to new node. So temp of next equal to new node. So this is the most asked. This is the three important lines. These are frequently asked in many interviews. So if you didn't understand this code, I mean this snippet code, I'm going to explain the diagrammatic representation. So initially, so this is our initially three nodes. So let me write here. So these are the three nodes: 10, 20, 30. So this is the previous, this is the next. So this is the next, this is the previous. So this is the next, and this is the previous. So not 30 actually, 40, right? 40. So then, so 40. So 40. So now we are going to insert 30. So 30, right? So first we need to initially temp points to the head. So this is the head. So at position 3, right? This is the position 3. So it's gonna stops at position 2. So temp becomes this 20, right? It gonna moves to here. So now temp will be updated to 20. 20, right? So this is the new node. So now initially these two is connected, right? So now we are going to change it. So we are going to erase it here. So now we are going to erase it. So now this connection will goes this like this will go like this. So what happened? First we are going to connect temp of next equal to what we have done, temp of, sorry, let me write. So I'm a mistake I had done. So initially what we have done here, new node next becomes temp of next. So I have all written right here, so I don't need to write again. So first we have what we have done. First we have new node, we have declared new node equal to new node next equal to temp of next. So new node previous becomes temp, yes. So new temp of next of previous becomes new node, yes, temp of next. So temp of next means this. So this previous becomes new node, yes, this one new node becomes. So this is what all about the insertion at beginning of a double linked list. I mean insertion at any position of the linked list. So let me see the C code. So I have all written the C code. This is the C code. So hashtag include these two header files are very important, and we are declared in struct node with int data next and previous. So struct node star head star second star third, these are the four nodes. So for head second third we have allocated dynamic memory allocation, and we have given values here, and we have in position 3. So new node equal to, we have allocated dynamic memory allocation for new node also. So new node data equal to 30, we are used temporary variable, and we are moving temp to the required position before the position. So these are the four important lines as I mentioned earlier, and temp equal to head. So now we are going to start while temp, we are printing all elements in this while using this for loop. So the output will be 10, 20, 30. So let me ask you some question. Why do we update 4 pointers? So it because every node is in the double linked list has both previous and next pointers. So all links must remain correct. So this is why. So what happens if we forgot to update one pointer? The list becomes broken and traversal may fail. So what will be the time complexity? So the time complexity for this operation will be time complexity equal to big of n. So this is the time complexity. So this is all about the insertion at any position in the double linked list. I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching, and see you guys in the next lecture.